Here we have a pitot tube. A pitot tube is an instrument used to measure velocity. How it works is you can see at this location here, there are very small holes that go around the circumference of the tube. In the front of the tube, at the leading edge, there is another hole. This tube is really a tube within a tube, and the flow is going to be approaching the tube in this direction. The flow, which hits the leading edge here, will stagnate and produce a stagnation pressure, which is transmitted to the back of the pitot tube, and that pressure would be sent to a transducer through tubing such as this. You would attach the tubing to the back end, and then the other end of the tubing would go to a pressure transducer, which would measure again the stagnation pressure. Now, some of the flow will not stagnate at the leading edge here, but some will flow over the tube. The pressure that's felt as the flow goes over these small holes around the circumference is going to be the static pressure. That static pressure is transmitted through the annular section of this tube and is felt at this position here. And so again, a second tube would be attached here and then brought to a transducer. Let's see this in practice in one of the experiments. This is going to be the small wind tunnel. Here we have the pitot tube attached to the small wind tunnel. You can see the tube that measures the static pressure, which is coming out the side, and the tube that measures the stagnation pressure, which has a red stripe on it. These two tubes are connected to the digital multimanometer, and the digital multimanometer has the tube with the red stripe, which is the stagnation pressure. That's hooked up to port 20, 21, 22, 23, and the static pressure is hooked up to port number 22. It is important when you're measuring velocity to make sure that the pitot tube is parallel to the flow. So the flow in this wind tunnel is moving from left to right on the screen, and therefore we have to make sure that the pitot tube is in line with the wind tunnel as such. If during the experiment the tube sags for any reason or gets bumped into, this will lead to inaccurate results, as the pressure that is felt at the leading edge is no longer the stagnation pressure, and the pressure along the static ring would no longer be the pure static component. But both of these ports would have some combination of both the stagnation and static pressure, and they would not be isolated.